Okay, hello folks. We are back. I mean, not back exactly, but yeah, here I am with another project that I made today. So this is something that I got inspiration from a YouTube video that I watched, and it is basically a prompt-based animator. Like you write some prompts here and generate scenes for you. So before demoing it, let me just get a quick overview of how it works. So there is this front end where you enter your prompt, basically what you see here, and it goes to the backend, which is currently running on a render, and then it talks to Gemini. For now, I kept Gemini as AI service provider, and it returns the following: scene, narration, and code. Something that I'm working on is adding TTS to it so it can have an AI generated voice. But for now, it generates scene, narration, and code. Scene, narration, and video ID. Basically, backend compiles all the scenes. Currently, it's generating 3 scenes, but I'll make more when I push to prod. So scenes and narrations are generated. Then the scene ID and the video ID is stored into the Redis, which is also working on render. Basically, I just wanted to deploy things fast, or I would have made a Docker file. But this happens, and the user can see what the scenes are, how they are working. And when they click on render scenes, it goes back to the worker. This worker picks up a job from Redis, which is basically for a video ID, for a specific video ID, and it compiles this. Now, how does it happens? It happens using a library called Manim. Manim stands for there is a open source project, which is a mathematical animation library. So it has all these circles, rectangles, and then equations to make animations out of them. And it's an easy library, but that's what the code that is generated by AI is written in. It is written in Manim library, which is also Python supported, by the way. So the tech stack that I've used here is Fast API, basic a React front end, and worker is also again Redis. Basically, there is no database, and yes, Supabase. So there the scenes are generated individually, and then they are compiled into one video. And though that compiled video is uploaded to Supabase, which is a bucket that we have here, the videos bucket, and then it is returned back to user as a URL, which we enter here. I'll get to a quick demo. So let's just refresh everything first, and let me get a quick demo. So explain gravity in brief. The results are hit or miss. I'm not sure how those are. So the scenes are being generated here. This takes a while because I'm using free version on everything, just what I could scrape through things. So these are the scenes that are generated. What is gravity? Gravity is pull, gravity everywhere. And when I click on render video, I'll need to start the worker locally. Basically, the worker will be started here. Uh, Let me get the slash env bin python and worker.py. Yeah, this started, and when we click on render video, picked up a job, and then it starts rendering the scene. So it rendered scene1.py, then it rendered scene2.py. I get all these outputs in my local system like this: scene1, scene2, and scene3. So let's see each scene individually. What is gravity? This is an animation. Gravity is everywhere. So this sun and earth thing. The results are not well. There was sun, moon, and earth. This is how an object falls. So that's what it is. Now we get the compiled video here. I'll get a better demo here when I upload this video. But this is how it works. So what is gravity? The quality is not good because I'm thinking of having a multi-stage rendering here because currently it's just in 480p 15. So I wanted things to be easy and fast while compiling. I think there could be distributed worker architecture that picks up different scenes and renders different scenes, and then all these three workers combine. So yeah, that's what we get here. And also in Supabase, we get the main video here. So yes, this is the actual video. What is gravity? This is something that can be utilized by educators. Maybe if there are longer videos, then there can be someone who can use it on, let's say, YouTube channels. And yeah, this is how it works. So it picked up a job, it rendered these three scenes, it stored them locally somewhere here. Let me show you. Workers, there is a renders folder which is empty for now because I've kept the cleanup code. So there is an app here which does the routing. There is a generate route, there's a render route, and there is a status route. So whenever you go to the requests of this, so let's see how the request waterfall was. So, oh shit, we'll have to do this again. Okay, let's do this again. Okay. So generate is awaited. This is the longest request that it takes because it compiles the scenes. So it returns everything here. So scene ID, titles and gravity pulls, and also a video ID, which is then sent to this render video. Okay. Then this render video has this job, and after this job, it keeps polling. So rendered scene, everything is here. Status is queued, status is queued, status is queued, everything is queued here. Okay. And okay, let's get back here. Yeah, it is queued for now. Yeah, it picked up a job, so here it will be in progress, in progress, in progress, rendering scene 1, scene 2, scene 3, and that's how it works. So here what happened is Gemini put some random code, so only one scene could be generated here, which is how Earth moves along the sun. There can be multiple things that can be done here. Not only physics topics, there can be tougher topics here, but this is completely done by AI, gravity's effect. Let's give it another demo, which is explain, how do we share it? Covalent bond in carbon. Let's give it something tough. I think it will fail here. I don't expect it to work very well with this kind of complex statement because the free tier is not that. Oh, it gives something. Let's try rendering this. Okay. mm, okay, yeah, it was picked up, it was picked up here. Was it picked up? Let's see, was it picked up? No, it's still queued. Let's restart this worker. And does it pick up a job? Yeah, it picked up a job, and it renders scene 1, it rendered scene 2, it rendered scene 3. There are no failed scenes, all three scenes were merged. And let's see the video. I'm very excited. This was the first time I did with oh, okay, 4 atoms. Okay, 2 carbons, they share an atom. Oh wow, this is a covalent bond. There is some problems in colors and stuff, but that could be solved when I use higher LLM models. So this is something that I did. I'm going to Dockerize the worker architecture so that I'm able to finalize this. So what worker does is, it's a very big file, but the loop here starts from picking up a job in Redis. Oh, okay, I messed this up. Yeah, it picks up a job from Redis, and then it renders each scene using its index. So scene1.py, scene2.py, scene3.py, all these logs that you see here, and then it merges using ffpmg. That is the library that it's using for merging them. So that's what happens, and then it uploads to a Supabase bucket that I have running. And when it is done, it uploads the public URL to the Redis, and there is this status endpoint that gets the job details and scene IDs at once. So if not found, status pending, pending, queued, whatever we want here, it is fetched using this. So this is something that I started. Now I might push this to prod, I might not push this prod, but this is a good project and can be turned into something that is very useful for educators, illustrators and demonstrators. There can be complex topics here. So yeah, that's what I made. I'll attach a good demo to this in along with this video, so you guys can watch the demo and understand things better. Thank you.